Hello, and thanks for checking out Chemistry Connections on the Hopewell Valley Student Podcasting Network, a proud partner of hvspn.com, where students come together to publish content to share with the world. The opinions represented within this episode are those of the content creators only. Please enjoy the show.
Welcome to Chemistry Connections. My name is Dorothy Wong, and I'm your host for episode number 1, called The Chemistry of Polyester Shirts and Their Environmental Impact. Today, I will be discussing the structure of polyester, how it is made, why it is used to make shirts, and its impact on the environment. For our first segment, I'm going to talk about the basics of polymers and go a little bit into what makes a polyester a polyester. So, what is a polyester? A polyester is a type of polymer. But what are polymers? Polymers are chains of thousands of monomers which form a singular big fat molecule. And yes, it is just one molecule. It is not many molecules put together, like I thought before. Monomers are smaller molecules that can react with each other to form polymer chains, and this process is known as polymerization. Often, polymers are depicted as a diagram of a monomer with brackets around it. The brackets around it represent the polymer's repetitive structure of the monomer. A property of polymers is its amorphous nature, which I will mention later. But basically it means that the polymer chains are randomly bunched together as opposed to a crystalline structure where everything is nice, neat, and organized. The bonds within polymers are covalent bonds, but the bonds between the polymers are dipole, and London dispersion forces. Polyesters, in particular, are made by mixing an alcohol and a carboxylic acid. And this reaction forms an ester functional group, which is distinguished by the atom chain of a carbon atom followed by an oxygen atom followed by another oxygen atom. A property of polyester in general is that it's a thermoplastic polymer, meaning that this can be remelted and remolded after it has been formed. Whereas for thermosets, those polymers, after they've been made, cannot be melted again and remolded. If you heat it, it just burns and it smells bad. So maybe we shouldn't do that. The most common type of polyester, though, is polyethylene terephthalate. This is also known as PET, or number 1 in recycling plastic to the general public. Some properties of polyethylene terephthalate are its high strength, low shrinkage, and chemical resistance, making it ideal for plastic containers and clothing. For our second segment, I am going to talk more about the process of making polyethylene terephthalate and some of its properties. So the process of making polyethylene terephthalate fiber, which is used in clothing, obviously, starts with the condensation reaction, which occurs between ethylene glycol and dimethyl terephthalate. This ends up becoming a monomer, which contains the classic ester functional group COO. The monomers, once they're formed, though, react once again with more dimethyl terephthalate and form the polymer that we all know and love, PET. The now molten polyethylene terephthalate is formed into long strands that can cool and dry. They are then broken up again, melted, and spun into fiber. And the final product is the polyester fibers that can be dyed and turned to the clothing that we all wear. The chemical bonding within polyethylene terephthalate is covalent bonding, like all polymers. Covalent bonding occurs when there are two atoms that want to bond together, but they are unwilling to part with their own electrons, causing them to share the electrons rather than part with their own. This can generally be found by looking at the difference of the atom's electronegativities. When the difference in electronegativities are small enough, there is covalent bonding. One pair of shared electrons makes a single bond, two pairs of shared electrons make a double bond, and three pairs of shared electrons make a triple bond. Within the ethylene terephthalate, though, there aren't any triple bonds. It's just made of single bonds and double bonds. Polyethylene terephthalate, as I said before, is amorphous solid. There is a benzene ring that can be found in each monomer part of the whole polymer. And this benzene ring limits the mobility of the groups that are attached, meaning that when polymer chains are put together, they can't be properly arranged in that nice crystalline structure that we see in ionic substances, and that is what contributes to the amorphous structure. The amorphous nature also allows for a transparent appearance, which we can see in the plastic water bottles that we use. The shirts, though, are not transparent. Dyes are usually added to them to get the desired color. I am interested in the environment and the different factors that negatively affect it. This past summer, I went to a sustainable polymers camp, and I was really intrigued by the large reach that plastic has on the environment. One talk that really stuck with me was one about microplastics. In the lecture, the professor, Anne McNeil of the University of Michigan, mentioned that millions of microplastic particles from synthetic materials in our shirts and other clothing are released into the environment from every single laundry load that we do, which kind of like a shock to me because it's such a common thing that we do, and yet we are not aware of its negative impact. Polyester is one such synthetic material which does affect the environment, and I just thought it'd be interesting to see its structure, learn more about it, and its properties. Thank you for listening to this episode of Chemistry Connections. For more student-ran podcasts and digital content, make sure you visit www.hvspn.com.